Electric force, Coulomb's law. Remember earlier on where we had a plastic ruler and we rubbed it with some fur and it obtained a charge and then it attracted neutral bits of paper. Let's look at it more closely and see what happened. So we're going to start with two rods here. We have rod A, which is neutral, and you can see that it has an equal number of negatives and positives. That's how we show that it's neutral. And we have another rod over here, rod B. See how we have more negatives there? That's telling us that it's a negatively charged rod. And they're very far apart. The question is, what happens to the charges on rod A when we move it closer towards rod B? When rod A, this one over here, is brought closer to rod B, the electrons, or the negative charge carriers in rod A, will be repelled by all the negative charges over here. You can see we have a preponderance of negative charges there. So the negative charges in rod A will move to the left side, and so when the negative charges move to the left, you're left with a net positive charge on the right. And remember, it's the electrons that are moving here, certainly not the protons. So what we have now is a polarized rod. We still have a neutral rod here. Rod A still has an equal number of negative and positive charges, but the negative ones are to the left, positive are to the right. And again, we call that polarized. We now have the positive charges on the right of rod A closer to rod B than its negative charges. So it will feel a net attraction towards rod B. And it will move towards rod B when we let it go. We can just let it go here now without pushing it, and it will move on its own and be attracted to rod B.